Hi everybody, I'm Janie Helms and I am giving a presentation on the urinary system and how it helps or processes through plasma concentration. So what plasma concentration or what plasma clearance is, it's basically the end of the kidney process, expelling wastes or extra water from the body. Now, when we talk about plasma clearance, we look at the concentration of substances within it and how much of that plasma is cleared of those substances each minute. So it's not about how much substance comes out of the plasma. You know, I could have 2 milliliters versus 10 milliliters. They're not looking at specifically how much comes out of it. They're looking at what percent of the plasma is cleared of substances. So is 100% all that substance was taken out? Was half of it left? So 50% of the plasma was cleared. And what it does is it really shows how effective our kidneys are. So if something is cleared, it will wind up in tubules that will exit in our urine. And there's 4 different ways that this process works, 4 different ways depending on the substance of what is actually cleared from the plasma versus what is reabsorbed back into the body. So option 1, or pathway 1, is when a substance is not reabsorbed back into the body at all. It is not secreted, meaning it's not held back in any way or stored. So that means 100% of that plasma was cleared of the substance. So it's going to end up coming out in our urine. And an example of that is a carbohydrate called inulin. And they consider it a foreign carbohydrate. It is found in Jerusalem artichokes as well as in lesser amounts of onions and garlic. Makes me think maybe why if someone eats an overabundance of garlic, why we can smell it either in pee or coming out of our pores. It's the inulin that is not absorbed back into our body for usage. Option 2, let's say that it's the complete opposite. Every single bit of that substance is reabsorbed and goes back and travels into the plasma and is taken and reused somewhere else. So none of it is cleared, 0%. And an example of this would be glucose. Glucose you don't normally find in the urine. If it is found in the urine, that means something is wrong, maybe in your kidneys or your pancreas. Usually a problem with like diabetes or something like that. But glucose naturally should not be found in the urine because all of it is reabsorbed back into the body. Option 3, only partially. So part of it is reabsorbed and part of it, or it's not secreted at all, but partially is reabsorbed. So, you know, we say that there's about maybe 50% or at least a partial clearance. An example of that is an organic compound that combines or is made of carbon, oxygen, nitrogen, and hydrogen, and it's called urea. And then option 4, it's not absorbed, but it is actually secreted. So I still have a plasma clearance of 100, an example of hydrogen. So if hydrogen ions are not bonded to something else, if they are not picked up, if they are not stored somewhere, they will exit through the urine. So let's talk about a case study that was done looking or studying plasma clearance, and specifically in the plasma, they were wanting to look at and compare the glomerular filtration rate. And so it deals with the clearance and what materials can move through or be absorbed or not absorbed and pass through the urine. So in the past, measuring GFR, which is the glomerular filtration rate, they used a standard technique that did not involve taking urine samples. And according to that, they used inulin as their example, because inulin is not supposed to be reabsorbed. It is 100% cleared from plasma and exits through the urine. So the standard technique confirmed that, except it had never been looked at in edema patients. So after that was established, some studies thought, well, I think that the GFR, that standard technique, is overestimating how much of that is cleared. So this case study chose to reevaluate those relationships, reevaluate both on a systemic and a renal inulin clearance. It wanted to compare both of them and use a different method than the standard technique so they could compare back to standard to see if it was a reliable version when talking about that clearance or the filtration rate. So their method of doing this, they wanted to look at both the systemic and the renal clearance at the exact same time. They chose 16 healthy patients, as well as to address the edema patients. So they chose 8 with the decompensation liver cirrhosis. Now, all of these patients, none of them were known to have any drug allergies and were also, even with the edema, were not on any regular medications. So to do actual calculations to see how much renal clearance or systematic clearance occurred, they looked and used the plasma concentration time curve, also known as AUC, after the patients were given a bolus intravenous injection. So to do the renal clearance, they looked at when they collected urine. So again, the standard technique did not look at urine, but this method they were using it. So for the renal clearance, they were taking the total amount recovered in the urine and dividing it by the AUC. The systemic clearance was taken by how much dosage they were given and dividing that by the AUC. So the process, what they did to actually test this out, those patients, both the 16 healthy as well as the 8 edema patients, they made them fast overnight, no food or drink. And then in the morning, every single patient was given 8 grams of inulin that was perfectly timed and evenly distributed through an infusion pump. And then afterwards, between hours 0 and 4, and then 4 to 12, urine was collected from each patient. And what happened afterwards was, after the 12 hours, all patients had at least 98% clearance. Here's the graph of their findings. So it shows the plasma concentration at the very beginning of the time limit. At the very beginning, they were up here at the top, or I should say at the first time that they chose. This was the concentration. And as you can tell, over time, less and less of that concentration, or the concentration became less. There was less of the material found. The dark enclosed circles represent the edema patients, and then the open circles represented the healthy patients. So when they came to their conclusion, after looking at their findings, looking at that graph, what they decided was using the urine method, actually looking at the urine and not the standard technique, it was simpler and definitely more precise or more specific numbers, kind of a better outcome to evaluate. However, as said with the previous studies and the thought process of measuring GFR, it was validated. Both renal and systematic were almost identical. You can tell that the edema patients were a little slower at one point, but eventually they caught up, and both healthy and unhealthy patients were evenly at the same ending point. So this case study, although using the different method, confirmed that the standard technique did not overestimate. It was a very, it was a confident method and correct method to use. It did get the right outcomes, the same as using urine samples. Some people just thought urine samples were the better or more precise way to go. And here are my references.